All right, so let's look at question 21 in the review packet. Find the values for each variable below. So we have, let's run through all 6 of these. Okay, so the first one, problem A. So this, again, it's a little bit blurry, but you can see that these are marked congruent, and these are marked congruent, and this is also marked congruent. So let's take a look at what we have here. This is a 90-degree angle. So if I focus on the larger triangle, and I notice that these are congruent, I know I've got 90 degrees to split between those two angles. So that tells me that both this and this are 45. Okay, so this is 90 and this is 45. Now, what I next realize is, wait, I've got another isosceles triangle. I've got a little one right here in purple. So what does that do for me? Well, that tells me if this is 45 and these are isosceles, this is 45. So S is 45 degrees, R is 45 degrees. Going to B. Well, the first thing I look for is any kind of number, and I find one over here, and I say, oh, well, if this is 125, look at this, that's a linear pair. So X must be 180 minus 125, which is 55. I have congruent triangles. I say, oh, the angles opposite the congruent sides have to be congruent. So this has to be 55. And then I think, oh, look, I got another linear pair going on over here. Well, 180 minus 55 is just going to bring me back to the 125. So I've got X and Z pretty easily. And then, of course, I can find Y with the triangle sum theorem. I add these two together. I get 110. Subtract that from 180 and get 70. So X is 55 degrees. Y is 70 degrees. Z is 125. I'm going to skip C till the end. Let's look at D. Here, these are marked congruent. Now, this one's a little tricky because you think it's an angle question, but it really doesn't have anything to do with the angles. It just says, well, these two things are congruent, and doesn't that mean that the algebra we've assigned to each of the sides must be equal? And that's what congruent means. They're going to be the same length. So that means I can set this equal to each other. Subtract the 2x from each side. I get negative x is negative 6, and x is 6. Moving over to E. All right, so again, I have to start with a number. So I can't start over here. I can't start over here. Oh, there's a 30. So I think to myself, all right, what do I know? Well, in this triangle over on the right, there's a 30, which normally wouldn't help me if I only had one angle, but I know that these two angles are congruent. So I know that I've got 150 degrees to split between these two angles, because that's 180 minus 30. And I think, oh, well, they have to be equal. So it can't be like 150 or 80 and 70, because then they wouldn't be equal. So I'm going to split them equally. So I'm just going to divide by 2. And if I do that, I get this is 75. And this is 75. And you might be thinking, well, why are you even trying to figure that out? Well, sometimes when I don't know where to go, I just start figuring out things that I know, and I go from there. Now, the nice thing here is once I have that these are 75 and 75, all of these that are single marked are 75, right? Remember, the little arc mark can mean congruence. And then once I have that, the rest of this becomes easy, right? Oh, 75 and 75 is 150, off 180, that makes 30. This is the same pattern, 75, 75, 30. So I get A is 30, B is 30, C is 75, and of course, all in degrees. Don't forget to include your degree symbol. Let's look at F. F is a little tricky. I mean, the main thing you need to recognize with F is that when you have an equilateral triangle like this, all of the angles are 60 degrees, right? You should know that from middle school, from Woodbury. We've had a few questions where you had to know that, but that's 60, and that's 60, and that's 60, and so on. You also should notice over here that, okay, on this triangle on the right, so this one I'm outlining in red, if this angle right here is 60, and these are congruent, well, I know that if this is 90, that's 90, so this is 30, so it's 30 over here, and I eventually figure out that this is 60. Now, why is that relevant? Well, here's what we have over on this end. We have that this is 60, and this is 60, and this is 60, and this is 60. I just kind of zoomed in on what's there, and this is angle Z. When you think of it this way, what do all these angles around the circle have to add up to? They have to add up to 360 because that's a full spin. So I just say 60 plus 60 plus 60 plus 60, that's 240. If I subtract that from 360, that's going to be what's left over on Z. So for this one, Z is 120. I'm going to come back and do 12C in a different video.